So today we finally get to solve some equations that aren't just one step. So we've been doing equations, something like x plus 5 equals 25, right? What do we need to do to both sides?
25.
Okay, if we subtract 5 from both sides of the equal sign, it'll still be equal. What do these add up to?
0.
Okay, and we have a new equation. What does our new equation say? X equals 20. We solved some other equations that look something like this. Didn't we? What do we need to do to both sides of this equation? Good. Okay. So if I divide by 4, why divide by 4? Yeah, that way this becomes a 1, doesn't it? So we end up with 1 times x, and we're going to write that for a while, aren't we? We're all going to write 1 times x equals 5. Okay? So now, finally, we're going to get to some equations. No, I don't know. I was going to do the same one. Shoot. Here. So 4x plus 5 equals 25. So we're going to get two equations that take more than one step. All right. Now I've got this poster up here. See my exploding head poster? There's one back there too. Okay. 5 steps to solve an equation. You know how to do the first 3 steps, but we're not doing that yet. We are just doing equations with 2 steps, and they are the last 2 right here. Okay. So the step we're going to look at first is remove the constant from the side of the variable. So we need to talk about constant and side of the variable and everything. So there are 2 constants in this equation. You see them? There's one coefficient of the variable. This is the coefficient of the variable. We want it to be a 1, but that's actually the last thing we worry about. We really need to get rid of this constant right here first. All right? So what can I do to both sides? You already know. Okay, so these add up to 0, and then you rewrite the new equation. Every time we do a step, we rewrite the new equation. And if you don't, it's just not going to happen for you. You're not going to get them right. Okay? So we have 4x equals 20, and then we can just do our last step. We can divide by 4. That way we get 1 times x equals 5. So we have 3 equations here. This one, and that one. What number makes this equation true? 5. You guys thought about that a little too long. You thought it was a trick question, didn't you? Yeah, 5 makes it true. This isn't the answer, it's an equation. We can just tell what makes it true. What number makes this equation true? 5. What number makes the top equation true? 5. That's the point. We just simplify it down until we can see the solution here, and it's the same all the way back up. Okay? So that's the number that makes the equation true. Let's look at that same equation for a minute. What would happen? Wait, this was a 25, wasn't it? 25. What would happen if I got rid of this constant? What would happen if I subtracted 25 from both sides? Would I be breaking a rule?
No. Not necessarily, but it wouldn't be true.
It wouldn't help.
It wouldn't help. Yeah, it wouldn't be helpful, would it? I'm not breaking a rule. I'm doing the same thing to both sides of the equal sign. And, I mean, I would get 4x. What's 5 subtract 25? Negative 20 equals, what's 25 subtract 25? Now, we actually have to put the 0 there. You can't leave one side of the equal sign blank. You know, normally, we don't put the 0 when they add up to 0, but you can't just leave one side blank. You have to have something, and 0 is something, okay? So this new equation, it's still equivalent. The same number makes it true. We haven't broken a rule or anything, but was it helpful?
No.
No, it's not helpful, is it? Okay? So we have to think about that as we solve these equations. what's going to make the equation simpler? Like here. What do you think I need to do first? Okay, if I subtract 5, am I getting rid of the constant on the side of the variable? Does that make sense? That's going to be gone. So if I subtract 5 here and here, big add subtract line, these add up to 0. Do I need to put the 0 this time? No, because I've got a 4x. And 17 subtract 5 is? So it's not the constant on the left, is it? It's the constant on the side of the equal sign where the variable is. Now how do I make that a 1x? Divide by 4. What if this was a negative 4x? So what's negative divided by negative? So whatever it takes to make that a positive 1, right? And then this would equal a negative? Does that work? So negative 3 makes this equation true, it makes that equation true, it makes that equation true. We agree? Okay. Got a piece of paper? Here, write this equation down and show me both steps. Solve it, show me both the steps, just the way we've been talking about. Show me the work correctly. Okay, Jack, what'd you do first?
Minus the 6.
Okay, so we subtracted 6 from both sides. Did you all put the subtraction symbol down? If you don't, put it there, okay? We don't often forget to add when we're supposed to add, but a lot of times if we don't have a symbol here, we'll add when we're supposed to subtract. Okay, so it's something to remember. Did you cross those out since they add up to 0?
Yep.
And you rewrote a new equation. Negative 5m equals 2. Good? All right. Now what?
Divide by negative 5.
Okay, so we have to divide by negative 5. That's what gives us positive 1 times m right here. Did you all put the 1 down? Okay. Now, we could put 2 over negative 5 as our answer. But we need to remember, it's not just the 5 that's negative. The whole fraction is negative, isn't it? All right. So, truly the answer should look like this. Because this whole fraction is negative. But we probably aren't going to write it that way either, because don't you guys have a tendency to do this? Negative 2/5. Where's the negative? Can you still see it? Kind of gets lost, doesn't it? So where are we going to put the negative? Yeah, in the top. Put the negative in the top of the fraction. We're really saying the whole fraction is negative, not just the 2 or the 5. But it's a really good idea to put it in the top of the fraction. Okay? There. Who got it right? Pretty easy, huh? Let's take a look at one with more negatives in it. What first? Okay. So add 4 to both sides. Ooh, isn't this answer negative? Good. Okay, now what? Divide by -7 on both sides of the equal sign, right? What's negative divided by negative? Okay, so that gives me my +1. And again, what's negative divided by negative? So our answer is 17/7. And that's a fine answer. You don't need to change it to a mixed number or a decimal or anything. I mean, you could. Oh, that's 2 3/7. But it's not necessary while we're just practicing solving equations. It will be necessary, you know, if you're doing a story problem, let's say, for example, and it's how many, I don't know, how many quarts of oil do I need? Well, if someone tells you you need 17/7 quarts of oil, like if you're out in the mechanic shop there, right, and your teacher's like, put 17/7 quarts of oil in that car, what would you say, Dallin? Huh? Well, that's what I would say. But if they said 2 3/7, so a little less than 2 1/2, can we say that? A little less than 2 1/2? That at least makes some sense, doesn't it? Okay, so on a real problem, we want to give an answer, probably a mixed number like that, or a decimal. But for just practicing solving the equations, you can leave it as an improper fraction. It's fine. What about fractions in the problem? Did this make you freak out last year? Who freaked out when you see those? I thought so. Okay. What's the constant on the side of the variable? -1/2. Good. Good. Well, how do I get rid of that?
Add 1/2 to both sides.
Okay. Add 1/2 to both sides. What do you think?
5, 4.
That work? Are 1/2 and 2/4 the same number?
Yes.
Are they?
Yep.
So if we had a number line, and I said put a dot where 1/2 is, and then I said put a dot where 2/4 is, would it be the same dot? Do you understand they're literally the same number? Okay, we're not changing the value here, just what it looks like. So these add up to 0. 1/5 m equals 5/4. And don't worry about 5/4, it's fine. Improper fractions, the name sounds bad. Oh, they're improper. But it's fine, okay? So, how do I make this say 1m?
Divide by 1/5.
Or times by its? Yeah, it's the same. Now, a kid came up to me last period, and he said, Mr. Collard, do I times by the reciprocal, or do I divide by 1/5? And I said, yes. Right? You're both right. I think yeah. So, doesn't this give me my 1? 1m equals 25/4. And again, that improper fraction is fine. Now, if you just have to, get out a calculator and do this on the calculator. Okay? But you still have to show me all this work. So let's say there's a decimal. We have a decimal problem. Because, I don't know, you might have one today on the assignment. Doesn't really matter. All right, what do you want to do first?
Add it and get it.
Okay. Now I'm going to be very careful about lining up my decimal here. This adds up to 0, so 0.4x is left. This is a little tricky. Oh, good. 0.04? Yeah. kind of like negative 16 and positive 20, isn't it? Now, if you have to, get out a calculator and do it. Okay, you get it to here. Now, we have to divide both sides by 0.4. Is it okay if I just write 0.4 and not 0.4? I mean, we can if you want. It doesn't matter. What do these do when we divide? 1. Okay, 1x. Now over here, I know 4 divided by 4 is 1, but the question is, okay, is the answer going to be 0.01? Is it going to be 0.001? Is it going to just be 1? Where's the decimal, right? Now we can do it. We can literally divide, can't we? So we make this a whole number. We'd move this one as well, put our decimal up here, and hey, 4 goes into 4, 1. Oh, so it's 0.1, isn't it? Can you get out a calculator and do that? Absolutely. Try to think first, though. And you'll notice all of these problems are kind of contrived. They kind of help you out. You can see what's going on a little bit at least, and have some idea what the answer is. You might have a hard time knowing where the decimal is or something like that. Okay, so over on page 108, you see the 4 practice problems? The first one starts 2/5 x subtract 3/10 equals 1/2. I want you to solve those for me, all 4 of them. And hey, on B, everyone see practice B? The one that says 9/4 x plus 3/7 equals 5/14. Does it say 9/4? What does it say? 2 1/4. Do I write down 2 1/4? No, because I know I'm going to have to multiply or divide at some point, aren't I? So mixed numbers are difficult to deal with. Just change it to an improper fraction right off the bat. Okay? So do all 4 of those. I'm going to give you 5 minutes. Show me the work. Show the work correctly.
What problem?
A, B, C, D. See the practice? Page 108. Okay. You got all four? Yes? Okay, Peyton, what first? Number A right here. Okay. So 2/5 x plus 0 equals, let's see, I think a half is 5/10. You guys agree? So 5 plus 3, that's 8/10. That wasn't too bad, was it? Okay. All right, Cooper, what now?
You divide 2/5.
Okay, so divide both sides of the equation by 2/5. So,
Oh, I mean,
yeah, divide both sides by 2/5. You're right. So times by its reciprocal. That's the same thing, right? Everyone, are you showing your work like this? What happens to this right here? And what are we left with? Okay, so that's a good thing, right? 1x. That's what we want. Equals, now we could say 40 over 20, couldn't we? But that does reduce down to 2. And you can reduce here first. Let's see, 5 goes into itself once and into 10 twice, and 2 goes into itself once and into 4. Hey, it's 2. However you get it, get there eventually, okay? Now, does your work look like mine? Do you show all the steps? Do you cross everything out? Okay, cover your noses up. Okay. Okay, B. What first, Jack?
minus 3/7.
Okay, so we're going to subtract 3/7 or 6/14, I guess. Everyone agree so far? Okay, so 9/4 x equals, now I did put my subtraction here so I don't forget. 5 subtract 6, that's negative 1/14. Righto? Okay. Stetson, what do you want to do now?
Now you divide 9/4.
Okay, so we divide both sides by 9/4. 4/9. 4/9. Okay, does this give us 1x, and our answer is negative. You guys okay with that? Think about that first. Answer is negative. Then worry about, okay, 1 times 4 and 14 times 9. I'm going to reduce. I think 2 goes into 4 twice and 2 goes into 14 7 times. So I see negative 2 over 7 times 9. So if we plug that back in our calculator, it should work. Where's my calculator at? Someone borrow my calculator?
Wait a minute, how do you get, oh, I thought you said 7.
How to get what?
I thought you said 7. Not negative 2 over 63.
Or you got 2 over 67?
No, I thought you said
Oh, maybe I did.
7.
Maybe I said that and wrote that down. I don't even know. Okay, I'm going to try this.
Yeah, I know.
Okay, so 9/4 multiplied by negative 2 over 63 plus 3/7. So when I hit enter, it should say 5/14, shouldn't it? Does it? Yay. Yay. That's it. Is it okay to check your answer using a calculator? Sure. Especially on a test, right? Yeah? What part of cover your nose with your mask are we not comprehending today? Are we getting it now? Okay, let's do that. All right. Let's take a look at C. So everybody wrote it down just like it is. What do you want to do first, George?
Add 1.4.
Okay. Now make sure we do it on both sides of the equal sign. Don't do it twice over here. Oh, it adds up to 0. That's good. So that constant's gone. 2.6 equals 20 times x. What do you want to do now, Jonah?
Divide both sides.
By?
2.6.
Well, if I divide by 2.6, that will give me a 1 over here, but I want the 1 by the x.
20.
Yeah, let's divide by 20. Good. See, that way we end up with 1 times x, which is what we're kind of after, right? Now, what about this 2.6 divided by 20? I know that answers 13 or 1.3 or 0.13. See, I know like 260 divided by, or 26 divided by 2 is 13. Let's say it that way. So I know it's in there somewhere. We can divide. Decimal up here. See, 20 won't go into 2, but it will go into 26 once. And we can drop down, let's see, that's 6, and drop down our 0, and 20 goes in to 60 13 times, and 0.13. Or can you get out a calculator and do it on the calculator? Peyton, can you do it on a calculator? Good, okay. All right, who did that right? All right. Okay, let's take a look at D. Oh, I wrote it down wrong. All right, Augustine, what do you want to do first?
Plus the 0.4.
Okay, so if we add 0.4 to both sides, so we add 0.4. No, do you guys notice how I lined up that decimal? These add up to 0, that's easy. But over here, I want to be really careful and make sure I get 0.56. Okay? Tommy, what do you want to do now?
Divide by 0.7.
Okay, so we divide by 0.7. Does this give us 1? Reagan says yes. 1x. Now I know 56 divided by 7 is 8. The question now is 0.8, is it 0.08? Where's the decimal? 0.8? Who got all 4 correct? Who got 3? 2? Awesome. Great. Okay. Everybody take a look at number 2 on the assignment. What operation is the inverse operation of addition? What operation is the inverse operation of subtraction? Why are we asking you about what's the inverse or the opposite of adding? What? Yeah, why?
So you can use it in this.
Yeah, when we're solving the equations, isn't that what we're doing? We're doing the inverse operation to get rid of it, aren't we? Or to reduce it to 1. So there's a reason we're being asked those questions. On 6 through 14, when you hand this in tomorrow, if your work does not look like this, I'm going to hand your assignment back and you're going to have a 0. You have to write down the equation and solve it and show your work the way I've taught you to do it. Everyone understand? So no whining tomorrow if I hand it back to you? Okay, let's get set 25 done. Thanks, guys.